Hello, welcome to this session on geometric distributions. I'm going to try and introduce this for a nice little example. So imagine Liam ordering regularly from Pilker's Kebabs. On any individual order there is a 15% chance of an error on his order. So any type of error, he could get the wrong sauce on the kebab. So we're going to model this, we're going to look at this in the context of a geometric distribution. Now, geometric distribution is how long we have to wait for something to happen. So let x be the number of times Liam orders until there is an error. So the probability that x equals some value of x, or the probability of x, is p, 1 minus p to the power of x minus 1. X is always an integer because it's the number of times we're waiting for something. Well, what does that mean? That means the one probability that there is an error times the probability there's no errors to x minus 1. Well, sometimes we think about p as the probability of success, or an error in your order is not a success, but it's what we're looking for. So in general, it's the probability of success times the probability of no success or failure to x minus 1. Well, let's think in this case, let's say Liam's first error in his order is on the 10th attempt. You'd have 9 error-free orders, so that would be the probability of no error to the power of 9 times the probability of an error. There's only one way, so there's no choose function needed here. 9 errors, error to the power of 9, no error to the power of 9 times error. Now in general we use this notation, x is GOP. Now let's consider this, quite an interesting cumulative version of it. The probability that the first error comes in the first x orders. So I'm saying, okay, let's say I want the probability that the first error is anywhere in the first 10 orders. Well, what's the opposite of that? Sometimes it's easier to find the opposites, and the opposite of that is 10 error-free orders. So that would be 1 minus p to the power 10. Probability of no errors to the power 10. Well, that's the opposite, so I do 1 minus that. So those are your key formulae for this topic. Let's have a look at a question, and hopefully it will start to make even a bit more sense. So the probability that Liam has an error in his order, in any order, from Pilker's Kebabs in any one order, as I said, is 15%. Find the probability that the first error is on the 6th order. Well, first thing I want to write here is x is distributed geometrically 0.15. I always get a mark for that. In the mark scheme, they always say, okay, yep, you can have a mark for recognising actually what you're doing, as long as you write it in the right way. Even if you get everything else wrong, you've got a nice little mark there. Well, I'm working out the probability that x equals 6. 6 is the first instance of order. So I'm going to say, okay, there's my 0.15 for the one success. But preceding that, I've got my 5 failures, or my 5 error-free orders. So to the power 5, and I stick that in the calculator, and I get a spooky number, 0.0666 to 3 significant figures. That wasn't deliberate, it's just what came up when I made the question. Right, the first error is on or before the 6th order. Well, let's go back. Think about this, probability that x is less than or equal to 6. Well, that's the opposite of 6 error-free orders. So I do 1 minus in brackets 1 minus 0.15 to the power 6. So probability of no errors in the first 6 orders That's the opposite, so I do 1 minus that. Remember, sometimes it's better to find the opposite. And to 3 significant figures, 0.623. I did that calculation before. I've not done that in my head, I promise you. So the first error is after the 6th order. You've probably noticed already that's the opposite to part 2, and this happens quite regularly in questions where one question will set you up for the next. So we're going to say, okay, that is actually the probability that the first occurrence is greater than 6. It happens after the 6th attempt. So I'm just going to do 1 minus 0.623, and that should give me 0.377. So that is the probability that my first error will be after the 6th order. So I'm going to have 6 error-free orders, and then who knows what happens after that. You often get this little question at the end, state 2 assumptions. Well, I need 2 assumptions to make this valid. So you would say each order is independent, and also each order has the same probability. So it only really works if it's all independent and there's no effect from one order to another, which in reality they probably would be, so these are only approximations to real life. Let's just review what we've done there. So the probability that the first error was on the 6th order, probability of 1 success times 5 failures. On or before the 6th order, 1 minus 6 failures, or 1 minus 6 error-free orders. And then the third part is just the opposite of the second part. Pause it, maybe have a good look at those, and don't forget your assumptions. Hopefully that's made sense. It's a nice topic this, so I hope you've enjoyed the introduction. Thank you. Goodbye.